Okay. So there seems to be a bit of confusion when I'm talking about bases reacting irreversibly with water. Well, butyllithium is an example of a base that will react irreversibly with water. Essentially, whenever you see a lithium, get rid of it and replace it with a negative charge. So that's really a carbanion. If that's acting as a base, it'll take that hydrogen off. You'll get this. Water has a pK of 15. Butane has a pK roughly around 45. So we put the arrow firmly in that direction. And the pKa difference is greater than is 15 or higher, so therefore it's irreversible. We have a negative nitrogen, say NaNH2, and water. Well, NaNH2, think of that as NH2 minus. That can take that proton off. Gives you NH3 and hydroxide. So NH3 has, ammonia has a pK of 35, water has a pK of 15, point the arrow there, and it reacts irreversibly. If you have something, say, I don't know, like this base right here. If it reacts with water, well, water has a pK of this, pK of hydrogen next to a carbon, attached to a carbonyl, that's 20. Arrow goes in that direction, that goes here. But it's within 6, so there is a backwards reaction, so therefore this can react reversibly with water. Now, let's get to Cl minus. Cl minus. If you have that chlorine take the proton off, you get HCl and OH minus. Water has a pK of 15. HCl has a pK of 90 minus 5, so the equilibrium firmly goes to the left-hand side, and it's an irreversible. There isn't any reaction arrow going backwards. Okay, now I want to be very, very clear. Chloride is not reacting irreversibly with water. Because chloride doesn't react irreversibly with water, because if we did, we wouldn't have an entire ocean full of salt water. The key is here, this arrow here. It's not pointing away from these two. That means this reaction, chloride grabbing the H off of water, does not occur.